Okay, so today we're going to talk about margin of error. So let's review. We have P is equal to 0.65, N is equal to 528, and we want to find the standard deviation. So this formula is used to find the standard deviation, so you have to know this formula. So it's the square root of P times 1 minus P divided by N. So we want to find the standard deviation to the nearest thousandth. So my suggestion is that you make some index cards to write down these formulas that you need to know. All right, so my P is 0.65 and N is 528. So I will have my standard deviation is equal to, my standard deviation is equal to the square root of 0.65 times 1 minus 0.65 divided by 528. Just plug that into your calculator. So if you don't have your calculator in front of you, go get it. I'll wait for you. Just put me on pause. All right, so plug it in your calculator, the square root, 0.625, parentheses, 1 minus 0.65, close parentheses, divided by 528. Make sure this is all underneath the radical. And you get your standard deviation is 0.020, which is rounded to 0.021. That's the nearest thousandth. All right, so let's take a look at 2. In the sample space of 500 teenagers, 328 of them had never attended a popular music concert. Find the sample portion of those who never attended a popular music concert. So we have 328 out of 500 teenagers that never attended a popular concert. So just plug that in your calculator, 328. This actually gives me P. And this is 0.656. All right, so let's take a look at what it says about margin of error. All right, so margin of error measures how spread out the sample means are relative to the value of the actual population mean. This value is used to find the interval where 95% of the data would lie. This is confidence interval of the mean plus or minus the margin of error. Okay, so to find this, you take the standard deviation formula that we had above, and then you multiply that by 2. So what you need to know is that this 95% here is 2 standard deviations, okay, which is 95% of the data. So that's the margin of error. Margin of error is always 2 standard deviations, which is 95% of the data. So you have to know that. The margin of error is 95% of the data. All right, so in the formula, P is your sample proportion, and N is the total in your sample. The larger the sample size, the smaller the margin of error. All right, so let's take a look at this example down here. A survey of 528 high school seniors found that 65% already had career plans after high school. Determine the margin of error to the nearest thousandth. All right, so my P, my portion size, which is 65%, and we would change that to just the decimal, which is 0.65. And my N, my total sample size is 528. So my margin of error is remember the formula, 2 times P times 1 minus P over N. So that's 2, the square root of 0.65 times 1 minus 0.65 over 528. So my margin of error, so just plug that into the calculator. My margin of error to the nearest thousandth is 0.042. All right, so let's take a look at the last problem. All right, so it says here, a candidate's 95% certainty range. Now remember, 95% is 2 standard deviations. Range for his approval rating is 62 to 74%. So we would want to change those to decimals, so 0.62 and 0.74. So that's a range. That's an interval. That is two standard deviations. Find the margin of error and his current approval rating. All right, so 0.62 and I have 0.74. So what this represents from here to there, that is 95% of the data. So from here to here, okay, that represents 2 standard deviations from the mean. So this is 2 standard deviations above the mean. This would be 2 standard deviations below the mean, which represents 95% of the data. So then how do I get the mean here? How do I find the middle of these two numbers? So to find the mean, we're going to add the numbers, 0.62 plus 0.74, and then divide by 2, and we get 0.68. So that is my mean, 0.68 is right in the middle. And what this actually represents is his approval rating. Sorry. Okay, so now we want to find the margin of error. Now, the margin of error, you could do either side of this. It doesn't really matter. The margin of error, remember, is your 2 standard deviations. So you can either find the right side or the left side. It doesn't matter. I'm going to find the right side here. So that's going from here to here, from 0.74 to 0.68. So the margin of error would be 0.74 minus 0.68, so the margin of error is 0.06. Okay, and that's it. And we'll practice more in class tomorrow. Have a good night.